In this video, we're starting a new section 13.0. We're going to do the problem largest num. All right, so this is the start of doing recursive problems. Anywho, I have the file downloaded and open DrRacket, so let's just go over it. All right, going to scroll down here and look for the problem statement. So notice how the data design step is done. So let's just review the data design steps that are all checked off over here. So list of number is one of either empty or cons number list of number. The interpretation is that it's a list of numbers, and here you have two lists of numbers, all right? A list with 2 and 5, and another list with 2, 5, 9, and 1. All right, and here's a template for that. All right, so write the function largest that consumes a list of numbers and produces the largest number in the list. Finish the uncompleted steps function design of 1 through 5. All right, so finish all these steps for the design of largest. All right, pause the video. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you took a good swing at it. So now let's go over it together. All right. So first, as always, is the signature. So signature is gonna be largest consumes a list of number and produces a number. The purpose that produces the largest number in the given list. Let's stub this out. So our largest consumes a list of numbers. So you can name this parameter whatever you want. Generally, I like to be consistent with the template here. And it spits out a number, so let's just do 0 as a good dummy value. Now let's write some tests to illustrate what this function does so that we can get a better idea of how to write the function. So an empty list should probably do 0. That seems like a good default, right? Check expect. Largest, let's say cons 6 empty. All right, there's only one number in this list, and that should probably be the largest number, right? 6. All right, let's do another example. Largest, let's do one too long this time. All right, so let's just grab this over here. You could also use the number, the variable nums1, right? But usually since the text, the font in my screen is bigger for the video's sake, I don't want to have to keep scrolling up and down. But generally you guys should use the variables because data examples will get more complicated over time. But anywho, I'm just going to inline it here. So what's the biggest number in this list, right? Of 2 and 5. Well, 5 is the biggest number. Okay, and let's do one for 3 long just for fun. All right, generally with functions like these, you only need one that's too long, right? But I like to do one with 3 long just for fun, 3 or 4 long for example's sake. All right, because I'm going to show you guys how to step through it and stuff. And here we go. So what's the largest number in this list, right? 2, 5, 9, and 1. The largest number is 9, all right? All right, so that seems like a good set of examples to run against our stubs. Let's just make sure the examples are good. It seems like it's just mismatches, so we are good. Going to comment out the stub here. And going to use the template they gave us above as a scaffold. Going to rename largest here. And also here, right, every time we just trust that the recursion, right, that this function just fulfills its purpose, all right? All right. So, pause the video. Hopefully this should be all the mental scaffolding needed to solve the problem. I'm going to go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So looking at all the scaffolding that we did above, right? In the empty case, the base case is that we should just spit out 0, all right? There we go. All right, so the first list in this case is 6, in this case is 2, in this case it's 2, and etc. All right? So what combinator should we use? Well, we're consuming a list of numbers. So we should look in the documentation over here and look at functions that operate on numbers. In this case, you know, you're going to scroll down and do some research and try to look at what you need. In this case, I know that we're going to need the function max that takes in any list of any amount of numbers and produces the biggest number. All right. So I'm going to fill in this as max and I'm going to run it. And let's see if it just works. And it does just work, like so. All right. So how does this work on a mechanical level? I know it's pretty hand wavy that over here in this recursive call to itself, that we just trust that it fulfills its purpose statement, and it's not going to sit well with you guys, right? Especially those who are starting off with recursion. So what we're going to do is comment out all but one test. Usually you should pick like either, you know, the most complicated test here. All right, so we're going to pick this big long test and we're going to run the stepper to that. And while we're running the stepper, we're going to put it in table format over here, all right? So this is how you click the header over here, and this is how you expand the cell sizes right here. All right, so we're going to focus on the step number, the current state of the list, whether it's empty or not, the first of the list, and the rest of the list, all right? Just like I said in the previous video, so that we can get a bird's eye view of all the state of the variables. Okay, so let's just run through the stepper here. All right, so this empty just expands to quote parentheses, parentheses, the same thing. I went over that. All right, so now we're at the call to cons, largest of cons 2, 5, 9, and 1. So it expands to this. All right, is this list empty? That's false. I'm going to copy this, actually, and stick it here. All right, so that's the current state of the list. This is step 0. Is this list empty? We just went over it, right? It's false right now. So I'm going to actually space this there so I can tab back to it more easily. So it's false. It's not empty. All right. So next, we're going to hit the else case because this evaluates it false. The else is just a max. All right. So what's the first of the list is 2. All right. So that's what I'm going to put down here. All right. Next. What's the rest of the list? Well, the rest of 2, 5, 9, and 1. Well, it's 5, 9, and 1. All right. It's this list over here. So let's just copy it in. There we go. All right. So we're going to do next here. And we're going to call largest. We're in the recursive call. Let me go back, actually. All right. We're calling largest with the rest of the list. Right. So it's getting smaller. There we go. So we're at the next recursive call. And since we're doing this recursive call, we're doing this expansion here. So we are at another step into the recursive call. And the state is this. All right. Right. It's the rest of this list. The rest of the initial list. So it's getting smaller. All right. So we're in the recursive call. Is this list empty? False. All right. So next, let's see. Since that branch is false, we're going to the else case. The else branch is just a max, so that gets replaced out. That gets pushed up. All right. So max of first of cons 5, 9, and 1 is 5. All right. So that's the first of this list. Right, of this list, right? The first of this list is 5, so we're doing that. On to the largest of the rest of 5, 9, and 1, all right? Which is just cons 9 and 1, like so. We're gonna copy that in. Done. All right. So hopefully I can add a new cell here. I need to expand the table size, actually. There we go. I'm going to expand it a little more. If I can just, okay, give myself some more room. All right, so I said that we're in another recursive call, so 2, and we're starting off with this list now, right? The rest of cons 5, 9, and 1 is cons 9 and 1. So we're in step 2 of the recursive call. All right, so calling the largest with this expands to this con. Is this list empty? No, there's a 9 and 1 here. So empty hall of the list is false, like so. All right. So what's the first of the list? We're going to see that shortly. So this, since the list was not empty, we're expanding to the else case, and we're just going to push that max out up here for the else branch. So what is the first of cons 9 and 1? Well, it's 9. All right. So the first of this list is the number 9. All right, so next, and largest of the rest of cons 9 and 1 is just cons 1. All right, so we're going to copy that in like so, and we're going to take the largest of that list. All right, so this is the next recursive call. All right, we're calling largest again, like so. Largest of cons 1 and empty. All right. So next, is cons 1 empty, an empty list? No, there's a 1 in here, all right? So that's false. So that's false. I need to put that there. All right. And since we don't take that branch, we're hitting the else. The else is just a max, it just gets pushed up. All right, so what's the first of cons 1 empty. Well, it's just 1, right? Calling first on that is just 1, like so. All right, next. Now we're taking the rest of cons 1 empty, which is just going to be the empty list. All right. Okay, next. And we're at the final recursive call, right? We're doing another recursive call on the empty list this time. So let's just go over here, 4. Now the start of the state of this recursive call is the number 4. Wait, no, it's not the number 4, my bad. Is empty, is the empty list, right? All right. So it expands to this, like so. Now, is this list empty? Yeah, it is empty. There's nothing in this list, right? As you guys can see. So we're going to hit true, and we're going to hit this base case. And this is where recursion stops. We're going to hit 0. All right. So in this case, if we do empty of the list, yeah, this is true, right? And the first, this is an error, right? Because if we take the first of an empty list, it errors out. But the base case value is 0, right? So we're going to put value base 0, right? Because these are all numbers. So we want to see, you know, kind of all the numbers in sort of one row here. All right. So we're at the final evaluation, right? Since the base case evaluates to true, because this is an empty list, it's 0. So we finally see this chain of maxes, and we're going to see this evaluation here, all right? So what's the biggest number of 1 and 0? It's 1, all right? So that's this max of 1, 0, evaluates just 1. So now we're at the call of max 9 and 1. What's the biggest number of these two guys? Well, 9 is the biggest number. So this max of 9 and 1 collapses into the value 9. So what's max of 5 and 9? What's the biggest number here? Well, it's 9. Now what's the max of 2 and 9? Well, 9 is the biggest number of these two numbers. Check expect 9 equals 9, and we are good with this example. All right. So this is the bird's eye view of all the variables and the state of each recursive call. All right. Hopefully that will satisfy your urge of needing to see each recursive call and how it works mechanically. But again, you shouldn't be focused on that. You should be focused on the combinator and the base case, right? These two right here, and how to contribute to it. All right. So you can also get the answer here, right? If you're ever stuck, right? Really stuck, the hint kind of tells you the combinator, right? Here's the max, right? It sometimes tells you the combinator in all the functions that we use from the standard library built into Racket. Okie dokie. So, right, you can play around with these tests as well, right? What if I stick like an 11 here, right? Will I get a mismatch? Will it actually find the biggest number? Yeah, the actual value 11 differs from 9, right? Like so. So you can play around with tests and keep making more elaborate tests if you're, really want to stress test this function. Okay. Anywho, let's just hand this in, right? And make sure that we pass the server-side test. It's called 13.0, largest num. So it's this. And we're going to submit this. And I recommend you guys check the website and make sure you pass the greater side test. All right. And that is about it for this one. And I will catch you in the next one.